In this example problem, which is example 9.6 from Module 9 on acids and bases, this example puts together a lot of the concepts that we've learned so far in chemistry, and it gives a relationship between using chemical equations and now also the concentration molarity in determining how much substances we have of each compound in a chemical reaction. And so we're going to walk through this step by step. Example 9.6 states, how many grams of sodium sulfite can be produced if 500.0 milliliters of a 1.6 molar concentration of sodium hydroxide is reacted with excess sulfuric acid? So the very first thing you need to be able to do in this type of a problem is look at the reactants. The reactants are sulfuric acid and sodium hydroxide. And you're going to make sodium sulfate. So you were supposed to have memorized, right, that sulfuric acid is H2SO4. So we're going to react sulfuric acid, which is H2SO4, with sodium hydroxide, NaOH. You should notice right away that sulfuric acid is, of course, an acid, and it's a diprotic acid, indicated here by the fact that we have 2 hydrogen atoms in this acid. Sodium hydroxide, the hydroxide ion here should be an indication that this is your base. And so this is an acid-base reaction. And so in this type of reaction, you know that we are going to form a salt and water. So I've rewritten it down here, H2SO4 plus sodium hydroxide yields, you take the cation from sodium and combine it with the anion sulfate to form sodium sulfate, and then water, H2O. The very next step that you have to do, and should notice right here though, is you have to remember when forming ionic compounds what the charges are on each of these ions. If you remember that sodium ion has a charge of 1 plus. The sulfite ion, however, has a charge of 2 negative. And if you have forgotten that, all you have to do is kind of look over here at this acid, and if you remember that there are hydrogen ion, when it forms, is a 1 plus, and so you need 2 of those for every 1 sulfate, although this is a covalent compound. So this equation right here, the way it's written, is not correct. So I have rewritten it here. So the first thing in balancing this equation is that I know that in order to make sodium sulfate, in order to make this a neutral compound, I need 2 sodium ions for every 1 sulfate polyatomic ion. And once I do that, then I need to go back and make sure each side is balanced. And I know that for the complete reaction, both of these 2 hydrogens are going to react with water. And so I'm going to generate 2 molecules of water, which means I'm going to need 2 molecules of sodium hydroxide. So on this side I have, there's 2 hydrogen here, 2 hydrogen here. So there's 4 on this side, and I have 2 molecules of water, gives me 4 atoms of hydrogen here. I have only 1 sulfate atom here, and that's true in the product side. For oxygen, I have 4 here and 2 here for a total of 6. I have 4 oxygen in this molecule and 2 oxygen molecules in water in the 2 molecules, so I have 6 on this side. I have 2 sodium atoms. There are 2 sodium atoms here. And so everything is balanced. Now when we go back and we look at this reaction, it says it wants to know how many grams of sodium sulfite are we going to make if I use 500 milliliters of a 1.6 molar sodium hydroxide. And we're going to react that with excess sulfuric acid. So the 2 things that we want to relate, we're going to make sodium sulfate, and we want to know how much, or given how much sodium hydroxide that we're going to use. And we have excess sulfuric acid. And so here I've written down what we have. We have 500 milliliters of a 1.6 molar solution of sodium hydroxide. What I want to know is how many grams of sodium sulfate will that make, right? And the other information that we can take away from this equation is that for every 2 moles, remember these coefficients relate moles of the compounds and give us a ratio for all the other compounds in the equation. So in this case, we have 2 moles of sodium hydroxide. We will make 1 mole of sodium sulfate. So this is the given information. But in order to use this conversion factor right here, we first need to know how many moles of sodium hydroxide do we have. And the way we do that is by using the information here for our volume. So in a 1.6 molar solution of sodium hydroxide, I know that I have 1.6 moles of sodium hydroxide for every liter. That's what I'm starting out with. That is the concentration. I have 1.6 moles of sodium hydroxide for every liter of solution I have. However, in the problem, we are told we only have 500 milliliters. So the first thing we need to do is convert this 500 milliliters to liters, because we need to keep our units consistent in order to multiply and divide. And so we remember that for every 1 liter, there are 1,000 milliliters. So this becomes, here's our factor label method. We start out with our 500 milliliters and divide by 1,000 milliliters. And in keeping with significant figures, we have 0.5000 liters. All right. And now, how does that help us? If I take 5 tenths essentially, or 0.5000 liters of a 1.6 molar solution of sodium hydroxide, okay, it's a multiplication problem, I will come up with 0.8 moles of sodium hydroxide. Our liters will cancel, and that will leave us with how many moles are in 500 milliliters, or a half a liter of the 1.6 molar solution. And however, even though this multiplication comes out to be 0.8, because I have 2 significant figures here, I have to write this as 0.80 moles of sodium hydroxide, because this first 0 is not significant. And we need this information to have the final answer come out correct. Okay, so to find out how many moles are in that 500 milliliters, we do a multiplication problem here. So now we know how many moles we have, and now we can go back and we can use this relationship to find out that how many moles of sodium sulfate we can make. All right, so we don't have 2 moles, we have less. We have 0.8 moles of sodium hydroxide. All right, so again, here's our equation. We have excess sulfuric acid, and we're going to add, for every 2 moles of sodium hydroxide, we're going to generate 1 mole of sodium sulfate. And I've just rewritten that here, and of course I forgot to write in my moles here, but we want to make sure you're specific there. So we start out, what we have is 0.80 moles of sodium hydroxide, and in order to cancel those out, we're going to divide by 2 moles of sodium hydroxide, and that will leave us with the number of moles of sodium sulfate. And doing so it's 0.80 divided by 2, which will give us 0.40 moles of sodium sulfate. Again, we need 2 significant figures in our answer. But we're not done yet, because the original question wants to know how many grams, not moles, of sodium sulfate that are being made. So we need to know then how to relate moles of sodium sulfate to mass. And the way we do that, remember, is to determine what the molar mass of sodium sulfate is. So to do that, we go back to the periodic chart, and what is the molecular mass for sodium sulfate. And to do that, we need the mass of each of the atoms of each of the elements present in sodium sulfate. And we have 2 atoms of sodium, 1 atom of sulfur, and 4 atoms of oxygen. And doing all that math, we find that we have 142.1 AMU is the molar mass of sodium sulfate. All this means is that if I weigh out 142.1 grams of sodium sulfate, I know that that 142.1 grams contains 1 mole of sodium sulfate. Now I have a relationship. I can go back and take my 0.40 moles of sodium sulfate and use this conversion factor. Right? So I'm going to multiply 0.40 moles of sodium sulfate times 142 grams of sodium sulfate because I know that's how much is in 1 mole. My moles will cancel, and this will yield 56.84 grams of sodium sulfate. However, I only have 2 significant figures here, and I have 4 significant figures here, which means my answer must have only 2 significant figures. So I can only go out to the tens position, which means I have to look at the number to the right. That is an 8, which means I have to round up. So your final answer will be 57 grams of sodium sulfate. So if we look back at our original question, how many grams of sodium sulfate can be produced if you use 500 milliliters of 1.6 molar sodium hydroxide with excess sulfuric acid? You will generate 57 grams of sodium sulfate. Okay. And that's shown right there. And that is it. Thank you.